Welcome to Math Simplified. This video is for 9th standard students. Today we are going to start a new chapter, chapter 6, Trigonometry. The topic is Trigonometric Ratios, exercise is 6.1. Please subscribe and share with your friends also. Trigonometry, okay. It is the branch of mathematics that studies the relationship between the length of the sides of a triangle and the angles of a triangle. So you know what a triangle is. It will have 3 sides and 3 angles. So there is a specific relationship between these angles and these sides, and that study is called the trigonometry. Okay, so here specifically when we think of a right angle triangle like this, ABC is a right angle triangle, this is 90 degree, we know that this is the hypotenuse, and by Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of its sides. So here it is AC square is equal to AB square plus BC square. This is the Pythagoras theorem. This is very important, please memorize it, because we are going to use it in all our sums. So sometimes they will give you the length of the hypotenuse AC and one of the sides, and you are asked to find the other side. Sometimes they'll give you the other 2 sides and ask you to find the hypotenuse. In either way, you can use this formula to solve and find out the length. Okay, here these are called Pythagorean triplets. That means if the 2 sides are 3 and 4, the hypotenuse will be 5. If the 2 sides are 5 and 12, the hypotenuse will be 13. 7 and 24, the hypotenuse is 25. Okay. Now let's see the relationship between the angle and the side. Okay, and this is true only for right angle triangles. Be careful about that. Remember that. Okay, so one of the angle should be 90 degree. Okay, so here is an example. This is a triangle, this is 90 degree, and we know this is the hypotenuse. So okay, if you take this is 90 degree, we will not consider it. There are other 2 angles here. Supposing you take this angle theta. Okay, so you have to look carefully now. What is the side opposite to this angle? It is this side opposite. Okay, BC. And the side adjacent to this angle is AB. Okay, and this is always the hypotenuse. Okay, the side opposite to 90 degree. Okay, so for theta, this is the adjacent side, this is the opposite side. If you take this angle C, what is the opposite side? It will be this side AB, and the adjacent side will be BC for this angle. Okay, hypotenuse will be this. So always be careful, always look at the angle which they are asking. If they say sine theta, you have to take this angle. If they say sine C, you have to take this angle. Okay, now let's find out what is sine theta. Okay, so sine of any angle, in this case it is angle theta, is opposite side upon hypotenuse. So what is the side opposite to it? BC. BC, and this is the hypotenuse. So BC upon AC. Okay, cos theta, this is the next relationship. Cos theta is adjacent side upon hypotenuse. So this is the adjacent side AB. Adjacent means the side near to the angle. Okay, adjacent side upon hypotenuse. So AB upon AC. Now tan theta is opposite upon adjacent. So what is the side opposite? BC upon AB. Okay, there are 3 more ratios, which is reciprocal ratios. This you don't need to memorize it. If you know sine theta, you can easily write down cosec theta. Okay, cosec theta is nothing but 1 upon sine theta. So what did we say? Sine theta is opposite upon hypotenuse. No, so cosec theta will be hypotenuse upon opposite side. Okay, sec theta is reciprocal of cos theta. So hypotenuse upon adjacent side. Cot theta is reciprocal of tan theta, adjacent upon opposite. So if you know sine theta, cos theta, tan theta, you can easily write down this. You don't need to remember these formulas. But this you should know. What is sine theta? Opposite upon hypotenuse. Cos theta is adjacent upon hypotenuse. Tan theta is opposite upon adjacent. Okay, let's go to the exercise. Question 1. from the given figure, find all the trigonometric ratios of angle B. Okay, so here they are talking about angle B. So be careful here. Now first write down what is the opposite side of angle B. AC is the opposite. What is the adjacent side for angle B? AB. What is the hypotenuse for 41? That is BC. Okay, so hypotenuse is 41, opposite side is 9, adjacent is 40. Now we can easily write down the ratios. Sin B is opposite upon hypotenuse, 9 upon 41. Cos B is adjacent upon hypotenuse, 40 upon 41. Tan B is opposite upon adjacent, that is 9 upon 40. Cosec is 1 upon sin B. So here it will be 41 upon 9 cosec B. Sec B will be 1 upon cos. So here 41 upon 40. You just have to flip it over. Reciprocal you have to write. Cot B is 1 upon tan B. So here tan, so it will be 40 upon 9. Okay. Next sum. From the given figure, find the value of, so okay. Let's first find out. Let's look at the given figure. They have given us this length they have given this. First let us find out AD. Okay. This is a right angle triangle ABD. Use Pythagoras theorem. So AD square is equal to AB square minus BD square. Use that, simplify, you will get AD as 12. Okay. Now take this triangle. So here is 12. So AC square is 12 square plus 16 square. Simplify it, you will get the value of AC as 20. So here AC is 20, AD is 12. Remember that. Okay, now let's find out sin B. Sin B is here, opposite side is AD and the hypotenuse is AB. So opposite side upon hypotenuse, 12 upon 13. Sec B is 1 upon cos B. First find out what is cos B. Adjacent upon hypotenuse, 5 upon 13. So the reciprocal 13 upon 5 is sec B. Cot B is 1 upon tan B. Write down tan B, opposite upon adjacent. So here it is opposite upon adjacent, 12 upon 5. So cot B is 5 upon 12. Cos C. Now let's be careful. Now you're gone to this angle. Okay, cos C, first write down what is the adjacent to cos C? DC. And what is opposite? AD. And this will be the hypotenuse. Okay. Cos C adjacent upon hypotenuse. So 16 upon 20. Here it is. Simplify. Tan C is opposite upon adjacent. AD upon DC. Okay. 12 upon 16. Cosec is 1 upon sin C. Sin C is opposite upon hypotenuse. AD upon AC. And the reciprocal will be 5 upon 3. Okay. Question 3. If 2 cos theta is equal to root 3, then find all the trigonometric ratios of angle theta. Okay. So here they have given 2 cos theta is equal to root 3. So what is cos theta? Root 3 upon 2. We know cos theta is adjacent upon hypotenuse. So this value will be the adjacent value of theta and this will be the hypotenuse. Okay. So if you draw a diagram like this and you take this angle as theta, then this side BC will be root 3 and this will be 2. Okay. Now let's find out AB by Pythagoras theorem. So AB square is equal to AC square minus BC square. So substitute and simplify, you will get AB as 1. Okay, now you found the length of all the 3 sides. Now let's write down the trigonometric ratios. Let's start with sin theta. Opposite upon hypotenuse. Opposite is AB and we know it is 1. 1 upon 2. Cos theta adjacent upon hypotenuse, root 3 upon 2. Tan theta opposite upon adjacent, 1 upon root 3. Okay. Now do the reciprocal and write down cosec, sec and cot. Okay. Question 4. If cos A is equal to 3 upon 5, then find the value of sin A minus cos A upon 2 tan A. Okay. Same way. Cos A is 3 upon 5. That is equal to adjacent upon hypotenuse. Okay. So here if you take this angle as A. Okay. So what is adjacent to A? This. So this side will be 3. Hypotenuse is here 5. Now by Pythagoras theorem, find out the opposite side of A, that is BC. Okay, that will be 5 square minus 3 square is BC square. BC is 4. Okay, now you got the opposite side also. Now write down sin A. Sin A is equal to opposite upon hypotenuse, 4 upon 5. Cos A is 3 upon 5. Tan A is 4 upon 3. Substitute these values in this expression. Simplify it, you will get the answer. Question 5. If cos A is equal to 2x upon 1 plus x square, then find the values of sin A and tan A in terms of x. So here again cos A is 2x upon 1 plus x square, adjacent upon hypotenuse. So let's draw the diagram. Here is A. We keep this angle as A. Okay, O is the right angle, B is here. So what is adjacent to A? This is this side. You write this as 2x and this hypotenuse as 1 plus x square. Now let's find the opposite side of A. Use the Pythagoras theorem. So OB square is equal to AB square minus OA square. Substitute and simplify, you will get BO as 1 minus x square. So this side is 1 minus x square. Okay, now let's find out sin A. They are asking sin A. Opposite side upon AB. So 1 minus x square upon 1 plus x square. Then they are asking tan A. Tan A is again opposite upon adjacent. That is 1 minus x square upon 2x. Question 6. If sin theta is equal to A upon root A square plus B square, then show that B sin theta is equal to A cos theta. Okay, so again this is opposite upon hypotenuse. So if this is theta, then this is A and this denominator is the hypotenuse. So write it like this. Find out BC. BC square is equal to AC square minus AB square. Substitute here, simplify, you get BC as this small b. Okay. Now let's find out, we know sin theta, let's find out cos theta. Cos theta is adjacent upon hypotenuse. So here is theta, adjacent side is this. So b upon root A square plus B square. Okay, now you found out cos theta. This is sin theta already given. Now take the LHS, substitute sin theta from here. You get this value. Take the RHS, substitute cos theta from here. You get this. Both are equal. Okay, so this shows that B sin theta is equal to A cos theta. Question 7. If 3 cot A is equal to 2, then find the value of this expression. Okay, cot A is 2 upon 3. That is adjacent upon opposite side. Okay, so here it is the angle A. Adjacent is 2 and opposite is 3. So write down like this. Find the hypotenuse by the Pythagoras theorem. AB square is equal to BO square plus OA square. Simplify, you will get AB hypotenuse as root 13. So here it is. Now let's write down. We want cos A as well as sin A. Okay, so first find out sin A. Opposite upon hypotenuse. So 3 upon root 13. Cos A is adjacent upon hypotenuse. 2 upon root 13. Okay, now substitute these values in this expression. So 4, 3 upon root 13 minus 3, 2 upon root 13 upon 2, 3 upon root 13 plus 3 into 2 upon root 13. So here the LCM is root 13. Okay, write down like this. It will get cancelled and you will get it like this. 1 upon 2. Question 8. If cos theta is 2, sin theta is equal to 1 is to 2, then find the value of this expression. So cos upon sin theta is equal to 1 upon 2. Therefore, by cross multiplication, sin theta is equal to 2 cos theta. Substitute this in this expression. Wherever sin theta is there, put 2 cos theta. See here I have put. Now open this bracket. It will be 4 cos theta. 8 cos theta minus 4 cos theta is 4 cos theta. 4 cos theta plus 4 cos theta is 8 cos theta. Cos theta will cancel. You get 4 upon 8. That is 1 upon 2. Question 9. From the given figure, prove that theta plus phi is equal to 90 degree. So we have to show that this angle theta plus phi. This full angle is 90 degree. Okay. For that, first what we are going to show is that AB square is equal to AC square plus CB square. That if we can show that, it means that this is a right angled triangle. Okay. Now let's find out the value of AB square. This is 9 plus 16, 25. So AB square is 25 whole square, that is 625. Okay. Now let's find out AC square plus BC square, that is 15 square plus 20 square. So here it is also 625. That means this satisfies the Pythagoras theorem and this angle is 90 degree. Theta plus phi is 90 degree. Also prove that there are two other right angle triangles. Okay. Now here you can see there is one triangle, there is another triangle here. They are asking us to show that this is right angle triangle. Take this triangle ACD. Okay. Here this is the hypotenuse, 15 square. So find out the value of 15 square. Then find out 9 square plus 12 square. So you will see that 15 square is equal to 9 square plus 12 square. Therefore, this triangle, by Pythagoras theorem, this triangle is a right angle triangle. Similarly, take this triangle DBC, this triangle. Find out BC square, that is 20 square. Then find out 12 square plus 16 square. When you add them, you find that this is equal to 20 square. Therefore, this is also a right angle triangle by Pythagoras theorem. Okay. Then lastly, they are asking us to find sine alpha. Okay. So this is the angle alpha. Sine alpha is opposite side upon hypotenuse. So 12 upon 15 sine alpha. Simplify, you get 4 upon 5. Cos beta. So this is beta here. Cos beta is adjacent upon hypotenuse. 16 upon 20. Simplify, you get 4 upon 5. Tan 5. So here is 5. Tan phi is opposite upon adjacent. 16 upon 12 is equal to 4 upon 3. Question 10. A boy standing at point O finds his kite flying at a point P with a distance of OP is equal to 25 meter. It is at a height of 5 meter from the ground. When the thread is extended by 10 meter from P, it reaches a point Q. What will be the height Qn of the kite from the ground? Use trigonometric ratios. So here is his first position. Then he extends the thread by 10 meters. So here is the figure. Okay. First take this triangle OPM. This is a right angle triangle. This is 90 degree. Okay. So sine of O is equal to opposite upon hypotenuse, 5 upon 25. Okay. Then take this full triangle OQN, this big triangle. Sine of O is h upon this side, 35. 25 plus 10, 35. So this is it. Both are equal. So h upon 35 is equal to 1 upon 5. H is equal to 35 upon 5, that is equal to 7. So the height h is 7 meters. Here we come to the end of the exercise. Please go through the video once again. Pause the video in each sum and practice them.